Okay, so on this one, it says we're going to use L'Hopital's rule. Let's be clear. What is L'Hopital's rule? It's when you have 0 over 0 or infinity over infinity, then you can take the derivative of the top and the bottom separately. And that's the key word, separately. Okay, well, first off, let's bring it down here. Let's check if we can even do Lopi. So let's just plug x is going to 0, right? Let's just plug in 0. See what we got. So that would be 8 to the 0 minus 14 to the 0 over 0. What's anything to the 0 power? 1. So this is 0 over 0. So when you get 0 over 0, you can use Lopi. So I'm going to use L'Hopital. So now I'm going to say use L'Hopital rule. So the way we officially do, we go equals, we put an H over it. That's how people often indicate that they're using L'Hopital's rule on that step. So, okay, what's L'Hopital's rule? Separate derivatives top and bottom. So I'm going to do just the top separately. Now, this isn't quotient rule, just the top separately. Now, how do you take the derivative of this? So let me remind you, whenever you have a to the x, the derivative, remember it's like e to the x, meaning he's our favorite, he does nothing, but it's not the perfect number, so it's times the ln of a. Do you remember that? That's the derivative rule for any number. Now, if you have e to the x, he is our favorite derivative. He does nothing. So if a is a number, that's because e is the perfect number, that 2.718, blah, 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 blah. He's the perfect number to be his own derivative. But any other number, when x is up in the power, remember, this is exponential. This isn't power. You can't go, I'm going to just bring down the x. No, no, no. Don't mistake if you have if you have x to the n power, the derivative, yeah, then the n can come down in minus 1. That's when x is in the base and there's a number in the power. But we have that backwards here. We have a number in the base and x is up in the power. When x is up in the power, that's called an exponential function. X is in the exponent zone. That's different when x is in the base and there's just numbers in the power. That's just the power rule. So when x is in the power, it's like e to the x. He's our favorite derivative, does nothing. So it's like that, but it's not the perfect number. So you got that little adjustment, L and A. That's not chain rule. That's the adjustment for the exponential function for any number other than E, the perfect number. All right. So what does that mean? So the derivative of this of 8 to the x is 8 to the x times ln A minus the derivative 14 to the x is, it does nothing like e to the x times ln of 14, because again, 14 and 8 are not the perfect number. They're not e. On the bottom, derivative of x, that's just 1. Now hold on for just a second. You might be like, what? What just happened? I did not do the quotient rule, right? So if you're thinking, hey, it's a fraction, don't you have to do the quotient rule? No, I'm not doing the quotient rule. Quotient rule would be derivative, they take turns, then you got to go over the bottom squared. I didn't do any of that. I did L'Hopital. What is L'Hopital? Top and bottom separately. That's a very special rule. It's only doable when you have 0 over 0, infinity over infinity. We had 0 over 0. So that said I can do L'Hopi. So I did derivative just the top all by itself, and then just the bottom all by itself. Okay, so what? Well, now we can plug in that, because x is still going to 0. So plug in that 0, plug in the 0. Right? What do we get? Well, we get 8 to the 0, ln a, minus 14 to the 0, ln 14 over 1. Getting to the 0 power is 1. This is 1 times ln 8 minus 1 times ln 14 over 1. The 1 at the bottom doesn't matter. And so that is ln 8 minus ln 14. You can just type that in, it's fine. There's also a shortcut. I don't know if you remember. 2 logs subtracted, you can make it 1 log divided. Either one. This is fine. This is fine. You don't have to do that special log trick. Both those are good. Remember, that's log properties from pre-calculus. If you have 2 logs subtracted, you can make that 1 log divided. Remember, what a harder job for 1 log dividing is easier for 2 subtraction. you can do that, but it's not required. So there we go. What did we do? We did LOPs, meaning we just plugged in the zero in the beginning, got 0 over 0, says you can do LOPI. So that meant drew the top and the bottom separately. We learned the rules, remembered the rules for an exponential. This is an exponential function. X is in the power zone, the exponent zone, with numbers in the base. That's like e to the x. He does nothing, but because he's not the perfect number, he has adjustment, ln a. That's not chain rule, that's adjustment. And then plug in the 0 again, and we just get ln of 8 minus ln 14, or divided. And there we go.